Welcome back, everybody. In today's lesson, we're going to learn about experimental probability. And so in the last lesson, we learned about theoretical probability, which studies what we expect is going to happen. Experimental probability describes what actually happened. So when you did a problem where someone was rolling a dice 100 times, the theoretical probability is what you expect would happen after that 100 times, and the experimental probability is what actually happened. So today we're going to determine the experimental probability of an event, and you're going to think about how our theoretical and experimental probabilities different and what similarities. You're going to do now on your own. Roll a pair of dice and add the numbers together. It's on your card, and these are the different cards over here. It's the first person to 10 points. What card do you want and why? So I'm not going to say too much, but you have to decide which of these cards is more likely to get you 10 points the fastest. Think back to that table we had. So first off, we're going to compare theoretical and experimental probabilities. It says Talia and Yoshi plan for 1 out of 8 or 12.5% of the players winning a prize. During the school fair, and winners, and recorded the data in the table below. How does the actual number of winners compare to the expected number of winners? So down here we have the number of winners and the total number of people who played. So I think it's important before we go further for you to write this down. So theoretically describes what you expect will happen. So again, that's like if you roll the dice 100 times, what you expect is going to happen. Experimental probability, which is the topic of today's lesson, describes what actually happened. So that would be after you rolled the dice 100 times, what actually happened, what were the results? So in step 1, it says determine the relative frequency of winners during each time period. The relative frequency is a ratio of the number of times an event occurred to the total number. So this is a relative frequency, and so is this. So these are all relative frequencies because it's a ratio that compares the number of times an event occurred to the total number of times. So it's a ratio that talks about the event happening compared to the total number of events. And events and these relative frequencies can be written as fractions or percentages. So the relative frequency of an event can also be called the experimental probability. We're going to compare the experimental probability based on the data to the theoretical probability of winning the game. So we know from before that this spinner has a probability of winning 1 out of 8 times, or 12.5%. If we look at the data of what actually happened, there were 58 winners out of 400. And so when you turn that into a percent, we get about 12.2%. So in the previous lesson, Talia and Yoshi expected about 63 winners for 500 players. Based on the theoretical probability, based on this data, there's actually 58 winners out of the 475. So there were slightly fewer winners than they were expecting. This is what was expected. This is what really happened. The experimental probability is slightly lower than the theoretical probability of winning this game. There were slightly fewer winners than expected. Okay, I'll do the next one with you. It says, during the second day of the school fair, Talia and Yoshi recorded 43 winners out of a total of 324 players. How does the actual number of winners compare to the expected number of winners? So this is what was expected. It was expected that 1 out of 8 people would win based on the spinner, and that's a 12.5% probability of each player being a winner. When we find the experimental probability, we take the total number of winners compare that to the total number of players. We do 43 divided by and we times 100. And so this would be about 13.3. The 7 next to the 2 is going to round the 2 up to a 3. So we would say that the experimental probability is more than the theoretical. And there were more winners than expected. This one on your own, and show that to me when your packet is done. You're going to do this one on your own. And in example 2, we've seen this before. We're using experimental probability to make predictions, except we did it with theoretical probability. It says Joaquin also kept track of players and winners for his game during the fair. Based on the results shown in the table, how many winners should he expect if 300 people played the game? Proportional reasoning to predict the number of likely winners, W, based on the experimental probability. So we take these numbers from the table, our first ratio, that's compared to W over 300 because of the 300 people. And then we multiply by 300 on both sides to get 51.2. So he should expect about 51 winners out of 300 players. I'll do this one with you. It says the best player on a basketball team makes 75% of all free throws. The second best makes 70% of all free throws. And the third best makes 65% of all free throws. Based on their experimental probabilities, estimate the number of free throws each player will make in his or her next 40 attempts. So first we're going to do 75%. So that's 75 over 100 equals x over, and we do times 40 times 40. It's 75 divided by 100, just 30. Next, for the 70% person, so we have 70 over 100 is x over 40. Same thing, we're going to multiply by 40. Times 70 divided by 100. Get 28. And then lastly, we have 65% over 100 equals x over x equals 26. In this last example, it says that Amir and Marvin split. The tables show their results. Based on the theoretical probability, what are the expected results of 50 coins? Two possible outcomes, heads or tails, and both outcomes are equally likely. So for each coin flip, the probability of landing heads up or tails up is 1 out of 2, or so after 50 flips, we should expect there will be a. Why might the results be different from the expected results based on the theoretical? So the theoretical probability can be used to estimate results. I'm going to underline that word. Estimate results, but they do not guarantee results. The more times they flip the coins, the more likely it is the results will be closer to the theoretical probability. Answer this question on your own, and these questions on your own. And then show me your packet when you're done, and then start working on the next step.